So for today's topic, we are going to discuss quadratic functions, okay, and applying transformations to the quadratic function. So we're going to be looking at how it is moving on the graph, and we're going to be looking at key features of the quadratic function. Okay, so anytime you're presented with an equation, okay, and it has 2 as the exponent, okay, we know that it is automatically going to be a U-shaped, right? So anytime we see 2 as an exponent, we know that our graph is going to be U-shaped like this, okay? Or it can be facing down, okay? But we know that that little 2 as the exponent means quadratic, okay? Whether it's written as a standard form, whether it's written as a vertex form, or whether it's just simply the x squared, right? Anytime we have 2 as an exponent, it is automatically quadratic. Okay, so next thing, I'm going to erase this so we have clean slate. So now anytime my directions tell me to describe the transformation or apply the transformation, okay, that just means we're changing our original parent function, okay? So that means the original parent function is always right here. It's always through 0, 0. Sorry, my vertex is a little off, but it always starts here. So if you were to graph that on Desmos, right, you can graph y equals x squared, and you'll notice that your vertex is at 0, 0. Okay, that is where every quadratic function will start. Okay, when you apply a transformation, you are either making it flip, stretch, slide from left to right, or shift up and down. Okay, and the best equation to use for this is vertex form. So when I look at this example that I'm displaying, I know that this is vertex form because if we remember the equation for vertex form, it looks like this. Y equals, that's the same as f of x, a parentheses x minus h squared plus k. So it closely resembles that vertex form. Okay, this one is the easiest to find transformations for or from. Okay, so what I like to do is read it from left to right. So I start at the equal sign and I'm going to work my way to the right, just like if I was reading words in a book, right? Left to right. So as I move through my equation, the negative sign is going to make it flip. The a value is going to make it stretch. So the negative sign and the a value, we've got to think of them as two separate items, okay? Because if I think of it as a -3, that's going to be less than 1, but this one is not going to stretch and get wider, okay? Since my a value is separate from that negative sign, I've got to think of that a as being bigger than 1, okay? I'll explain that a little bit further in just a minute. I want you just to know that that negative and the a are separate. Okay, so now I'm going to talk about those parentheses. Parentheses make it go left or right. So they're taking that parent function and they are shifting it left or right. If it is a negative, we've got to think opposite than we normally would, right? We usually think negative is left, but really that is right. plus inside parentheses would make it go left. So anytime you see parentheses, you've got to think opposite. And then now we have to talk about this number over here, that K value. That is what makes it go up or down. And these are just regular. Up is plus, minus down. So if I was reading this exact problem from left to right, I know that my parent function would have flipped down. So now I'm going to adjust this one over here on the side. It's going to be flipped down. I'm going to do one step at a time. That 3, because that A is bigger than 1, is going to make it get tall and skinny. So it's still flipped down, but now it's tall and skinny. Okay? Notice how my vertex is still in the same spot. Now I'm going to start moving it left, right, up, and down. I have a -2 inside parentheses, right? I got that x minus 2. So that means it's going to go right 2 times. So that means I'm going to take my vertex. It's still flipped down, tall and skinny, and it's going to the right 2 times. So now my vertex is here. It's tall and skinny, flipped down, but notice how it shifted 2 times to the right. And my last step is to move it down, because it's -4, right? So that means down 4 times. So my final location of my vertex will be down 2 places from here, and that is my final spot. Okay? So it did 1, 2, 3, 4 different things. It flipped down because of the negative sign. The A value made it stretch. It got tall and skinny. The parentheses, we've got to think opposite. Negative made it go to the right 2 times. And then this over here, this plus K, in our case, it's a -4. Minus made it go down 4 times. And so when I'm finished, my vertex should be here in this spot. So if I was pulling the vertex from this equation, okay, that -h, we're going to do opposite of that. Okay, that -2, I'm going to pull it out. So my vertex should be at 2, -4. And we're going to go check to confirm. 2, -4. So if I go check, I had moved it over 2, down, oops, I only did it down 2. Let's pretend we shifted it down 4. Sorry. -4. And we are right. Okay? So this is where my final spot is here in green. Hopefully that helped you better understand and you can answer some of those questions on the STAR review.